So, math homies, time to do one more today. Lesson 76. 76. That's right, it's when I was born. 1976. When Rocky came out. Yo, people, let's multiply some radical expressions. We've done radical expressions in several other lessons. So if you've been following the whole time here, then we're making progress. You know what I'm saying? Got a principle here. I wrote it in both directions. Though I could have just written it, and you could read it from right to left, or you could read it from left to right, and that would be the product property of radicals. Okay, so imagine, pick two numbers, whatever you want. Oh, okay. You can't. All right, I got it. Okay, so like 2 and 3. How about that? Does that sound good? Okay. 2 and 3. 2 times 3 is 6. Well, if it's just 6, we can split that up into its factors and put them each over the little dilly-dilly radicand there all by itself. We can split it up and use what we want to and leave what we want to. This would be useful if we had something like square root of 18. Some of you are like, where's my calculator? And I'll type that in and see what it equals. And I'm like, no, don't you dare do that. That would be silly. Well, I can break this down into square root of 2 and square root of 9. Hello. And I can do something with this, and I can leave that. So that's 3, and that's root 2, and that's better. And then you leave it like that. You don't you dare say, well, 2 is like approximately 1.414, blah, blah, blah. Well, approximately, okay? That's what, if you need a dictionary, you go look that up. It does not mean exactly. It means kind of close. But that's irrational. And you don't mess with that. You just leave it like that. It's like math, algebra, you can leave it like that. You don't use your calculator for stuff like that. No. Cut it out. You leave it like this. So that comes in handy there, where we can split something up and get to something that we can actually do something with. Pull that out and make it 3. It's exactly 3. And then we got times root 2, and that's perfectly fine. Sometimes we got a whole mess of stuff we want to put it under there and do something with it. Maybe that would be something like, let's do like root 6 and root 2. Okay? And this rule says that we can just cozy those suckers up underneath the root sign right next to each other. In fact, I'm going to take that 6, I'm going to break it down into 3 times 2. And now you see what I'm doing? Well, that's 2 squared. And I can do something with that, because I got the square root of 2 squared is 2. And so I can combine them and then kind of clean them up. Okay, and I get 2 root 3, which is a much better answer. Then square root of 6 times square root of 2, or even trying to do square root of 12 on your calculator. I just said don't do that. So cut it out. Ever do that? That just bothers me. I just can't believe these kids. They're always thinking like, oh, I'm going to do all my calculators. No! So we're going to use these principles here with, I'm going to give you a variety. I think I got I'm going to do 7 quick examples here, if I can stop chattering. And go through those and show you how you can multiply these radical expressions and clean them up a little bit, so we get like one answer, or we get an answer with 2 pieces, or something like that, something that is simpler and more usable in math land. Okay, so first one I'm going to do, some of these are examples out of the book, and some of them I'm just making them up, would be, let's just use some numbers here. And this is kind of like the example that I just did, where I'm like, well, I can't do anything with 8, well, I can make it 2 root 2, but I still have that root 2. I mean, I could do that. I'm going to do this in 2 ways, okay? I could take this and go like, that's 2 times 2 times 2. 2 of those can come out and get 2 root 2, and then I got this multiplied by root 2. I'm like, oh, look at that. I can do this again. I can go, oh, let's just do 2 times 2, and that makes 4, and that means times 2, and that means I get 4. That's That's just me talking. But look what happens if you just put them underneath one thing for starters. Okay? See all that mumbo jumbo? Here we go. Do it again. And go, I can use this rule right here and go, that 8 times 2 is 16, and that is, and that's 4. Saves paper, saves the environment. I mean, it's way, way better for you to do that. So that's one thing. Put them underneath the same thing. They can cozy up real nice and neat underneath that radical, and then you're like, wait a second, that's just something I can use. I'm going to do that. Okay, let's do another one. 6 root 2 times 4 root 5. It's got 4 pieces. No, thank you. No, thank you. Well, let's see. Which one is it? The commutative property of multiplication says that I can do these in any order that I want to. So I'm going to put the things not under radicals together. That would be the 6 times 4. I'm going to put the things that do have radicals next to each other, the square root of 2 and square root of 5, and then I can squish this down so I get smaller pieces. This part here is 24, and this part I can cozy up underneath the same root sign, and I'm thinking both prime numbers. Can't do anything with them if I smoosh them together. Here, I'll just get root 10, and then I quit. I don't use the calculator for that. I just go correct answer, full credit. There you are. That's much better than this whole mumbo jumbo mess. I'm going to stop saying mumbo jumbo, if possible. Here's another one. This one has got x in it. But again, commutative property says I can move these pieces around and do them in whatever order I want to. So I'm going to group 2 and the other 2, and I'm going to group these ones. And then I'm going to use this property here and cozy them under the same radicand. So that part's 4, and then this part I got a 3. I'm going to put the number next to it, the 2. And then I've got 2 x's, or x squared, and I go, yes, yes indeed. I get 4, I get a root 6, I get a square root of x squared, just grouped it differently, and I go, that just means x. So, I'm going to bring that answer out to the front and go 4, and x, and the square root of 6, and then I'm done. Because there's nothing I can do with square root of 6 to make that any simpler, and everything else has been pulled out and cleaned up, made tidy and new. Fourth example. Here we go. I'm moving. Fourth example. Distributive property. We're just using other stuff we've already done, except we're putting square roots in there, seeing if we can do anything else with it. This has to be multiplied by both of those things inside the parentheses, so let's do that. 2 root 2 times 4. Well, 2 times 4 is 8, and we got root 2, which we can't do anything with, and 2 square root 2 times negative square root of 3. So I can go negative, I got the 2, and then I'm going to just put them underneath one radical sign instead of under 2 radical signs. And so that's an 8 root 2 minus a 2 root 6. And please don't try to combine those. Please don't go like 6 root negative 4 or 6 root 8. I don't know what you would do with that, but don't. Leave it. This is like 8 apples minus 2 oranges. They're different from each other. Don't smush them together. Please. Please. There we go. This times that. Clean it up a little bit. Put those under the same radical sign. That's the property that we're learning about today. And finish it off and say, there it is. Fourth example. Fifth example. Oh, let's start talking about common Algebra 1 student errors. This one you probably won't make the mistakes, but everything in the parentheses, the squared gets applied to it. So this is 2 squared and square root of 7 squared. The reason for that is that this expression could be rewritten like that. Conceptually, that's what square means. It means all this multiplied by itself. So if we think of it like that, we're like, well, there's the 2 times 2, and then we got the root 7 times the root 7. There it is, it's twice. If you would like to, you can think of it like this: 2 times 2 times root 7 times root 7. And then you can combine those under one thing, like the rule says. And you know what that is, right? 7. So we're at 4 times 7 equals 28, and it cleans up nicely. 2 squared and square root of 7 squared is 4 times 7, which is 28. I did it the hard way. I could have just gone right here and gone, that's 4 times 7. All right, here's one that you would tend to mess up on. I see on Algebra 2 tests where people are like, well, that is 9 minus square root of 3 squared, which is 3, so that's 6. And I go, no! It's not that. This is everything in parentheses times itself. And this turns into a foiling problem. We go first, outside, inside, last. 3 times 3 is 9. 3 times that, negative 3, one of those. So you got another one of those. And then you got negative times a negative is a positive, and square root of 3 times square root of 3 is 3. So we've got grouping these things. We got a 9 and a 3, and we've got 2 of those, so that's 12. And this here is negative 3 of these, and negative 3 of these is negative 6 of these. That's a really great answer right there. But I do not do that other business. I take everything in parentheses and I just rewrite it right next to it. That's what squaring means. So this is the one that I see most often people mess up on. Throwing an X in there, it gets even worse. But please don't do that. Do this. Do this. Okay? Do as I do. Do as I do. Did you just do that? You should. It's good for your joints. Okay, here's another one that is likened unto that, but I want you to notice something that you can do right off the bat. The book kind of takes the stupid way of doing it and goes, let's just FOIL everything and not care about the form that anything's in right now, because I'm just going to ignore that. I already know what the square root of 9 is instead of doing it. No, I'm going to clean this up first. I'm like, square root of 9, I already know what that is. That's 3. Oh, look, 4 plus 3. I know what that is. That's 7. Okay, I just simplified this problem. Now I'm back to one of those ones I just did. I'm like, oh, I can do this. 7 times 2 is 14. 7 times that business is 7 of those businesses. And I can do that one faster than they did it in the book because I'm using the 2 pounds of gray matter up there. Maybe 1.5 pounds. Okay, whatever. I don't need any smack from you. That's better to do it that way. And one more. Just for fun, one that you might think you can combine pretty nicely, but you can't. This is a FOIL problem right here, so let's just see what happens. First, 3 times 2 is 6. Outside, we get 3 times the root of 3. Inside, we get 2 times the root of 2, and the last ones will get square root of 2 and square root of 3, which I can combine into square root of 6. Here, can I put these together? No, that's right, I can't. So I'm going to have this, I'm going to have that, I'm going to have one of these, and I'm going to have one of those, and these are all different. These are not like each other. Apples, oranges, and apricots. Peaches. Okay? That looks like it's not simplified, but it's the best. It is the best. You can't do it any better than that. Don't even try. So there you are. Multiplying radical expressions give you a whole bunch of different kinds. The ones in the book are going to have to look something like that. So need any help? Comment, call me, text. See you later.